Hey guys, it's Miss Vinson. So last time we really got a good introduction and a good feel for our cost terms. Now what we're going to do is see what those things look like on a graph. Now every one of the cost terms that we learned yesterday all have a place on a graph. So these are going to be our short run cost curves. Now let me walk through them step by step, and then we're going to end up combining some of them on the same graph together. First, let's think about total fixed cost. Total fixed cost never changes, right? This is like your rent. No matter how much you're making on your quantity axis, your total fixed cost is going to stay the same price, it's going to stay the same dollar amount. It would be a constant horizontal line. Some people do choose to graph that, but we're not, because it's already going to be hidden between two lines. So it would be unnecessary to draw the horizontal curve. It would just be redundant. Next, let's talk about average fixed cost. Average fixed cost always gets smaller. So if we were to graph average fixed cost, then this would be a curve that would just keep getting lower and lower. Now we're never going to graph this curve either. The reason being, average fixed cost is already going to be hidden between two curves on our graph. So if we were to draw this curve, it would be on there kind of twice. So let's not have our graphs any cluttered than they have to be. Finally, let's get to one we're actually going to draw, and that is average variable cost. Average variable cost is your labor cost per unit. Remember how we talked about our per unit cost get cheaper at first, and then for some reason they turn and start to increase? It's all about our workers, right? Whenever our workers are really productive, then that wage we're paying them is split up over all the units they're making, so the per unit cost is less and less. But whenever those workers are less productive, that wage is not split up over a whole bunch of units, and so our costs are bigger. So our average variable cost is a U-shaped curve. It's going to go down at first when our average productivity rises, but when our average productivity turns and falls, our average variable costs are going to turn and skyrocket. Well, that's going to be the same for average total cost. Average total cost also goes down and then turns back up. It's going to be a U-shaped curve as well. So if we were going to draw these on a graph together, here's how I draw it. First, I'm going to draw a U-shaped average total cost, and then right below that, I'm going to draw a U-shaped average variable cost. But you know what? Over on the right-hand side of the paper, I want it to look like those two curves are about to crash into each other. Now, I'm not just asking you to do bad art or a bad drawing. Think about the equation. The reason why your average total cost and average variable cost curves look like they're getting closer and closer and they're about to crash into each other is because what's in between them, average fixed cost, is getting smaller and smaller. Finally, let's talk about marginal cost. And it's going to be a U-shaped curve as well, but it's going to be a very dramatic U-shaped curve. The reason why your marginal cost goes down and then goes back up and skyrockets is because it's inversely related with your marginal productivity numbers. So the higher your marginal productivity, the more that next person can contribute, the lower your extra cost. The less that next person can contribute because things are crowded, the higher your next cost. So on your graph, where your average total cost and your average variable cost are at their minimum points, I want you to put a dot. Your marginal cost curve must intersect the minimum points of these average curves. The reason why is because of that marginal average relationship, how marginal pulls average around. So let's start drawing our marginal cost curve. Marginal cost curve is going to get low at first, and then it's going to turn and go up. Now notice at this point, it's still below both of your average curves. Well, if the next thing is lower than your average, it's going to keep pulling your average down. So notice that as long as this Nike check, as long as this marginal cost curve is literally located below your average curves, those average curves are going to be sinking and falling. As we continue to draw our marginal cost curve, notice how it slices and goes through the minimum of average variable cost. Well, at that point, whenever it crosses and goes above AVC, look what happens to AVC. It's starting to turn and go up. Why is AVC increasing? Because marginal is higher than that average, so it's pulling that average up. But it's still lower than ATC, so notice how ATC is still falling. Then as we draw the rest of our marginal cost curve, it is now higher than both of our average cost curves, and so now both of our average cost curves are being pulled up by that marginal cost. So this is your marginal average cost graph. Now, how do we read this graph? We read this graph at one particular output level at a time. So suppose that we're going to read this graph at a quantity level of 100. At this particular quantity, let's try to figure out what our costs are. Let's do the easy things first. Anything that's on the graph, we're just going to go up and hit it and read off the dollar value. So suppose we start at 100 and we go up and we hit our ATC curve. When you hit your ATC curve, go right over to the y-axis and just read the dollar value associated with that. Your ATC is $4.50. Well, what about average variable cost? Start at your 100, go up until you hit that curve, and then just go straight to the y-axis and see that's $3. Now we got to find our average fixed cost. Remember that AFC always gets smaller, so average fixed cost is always going to be that space in between ATC and AVC that keeps getting narrower and narrower. So we need to find the value of that gap. Now at a quantity of 100, that's going to be worth $1.50. So our average fixed cost is $1.50. Finally, if we want to find our marginal cost curve, we're just going to go up and hit that Nike check and just go over to the y-axis, and we see that our marginal cost is going to be $6. So what that literally means is the extra cost to make that 100th last unit was $6. And notice when we found these values, it was a vertical distance, right? When we found the value of marginal cost, we went from 100 on the x-axis all the way up to hit our marginal cost curve. That vertical distance was worth $6. Now you might think that's all that we can find from this graph, but with a little bit of math, we can actually find our total cost terms as well. Think about how you average, guys. Anytime you average, that's total divided by quantity. Well, check out what we have. We already have all of our averages, and we have the quantity. We know we're reading this graph at a quantity of 100. So if we're looking for our total values, and we already have our averages and our quantity, if we know how much it costs to make one thing and we know how many things we're making, then we're just going to multiply our averages times our quantity, and that's going to give us our total values. Remember to keep your like terms together, so keep AFC with TFC and AVC with TVC. So if we want to find total cost, then we're just going to do ATC times Q. Well, that's 450 times 100, so that's $450. That's how much we're spending to make all 100 units. If we're looking for total variable cost, then that's going to be average variable cost times quantity. That's $3 times 100 units. So that's $300 that we're spending on labor to make those 100 units. And then finally, if we were looking for our total fixed cost, we're going to do our average fixed cost times our quantity, and that's going to be $1.50 times 100, which is $150. So on this graph, guys, either you're going to go up and hit the curve that you're looking for and just read the dollar value straight off, or you might have to multiply to get your bigger numbers, to get your total values. Now notice to find the total values, we were taking the average prices, which were a vertical distance, and multiplying them by the quantity of 100, which is a horizontal distance. So when you find your totals on a marginal average graph, then what you're really doing is length times width. So total cost is just going to be a rectangle that's coming off of the ATC curve, and total fixed cost is a slice of a rectangle that's coming off of the average fixed cost vertical distance. You may be asked to identify or shade in these values on a multiple choice or free response question. Now this is your marginal average graph, and really the one you're going to be working with the majority of the time. But we have to talk about your total graph. Remember how we have these total terms? Well, they do have curves of their own. The reason why we have a completely separate graph for our total curves is because they're much bigger dollar values. So since they're in a completely different range on the y-axis, we can't put them on the same graph as how much it costs to make one thing. That would be like at the ceiling. So total costs go on a completely different graph. That's called your total cost graph. Now let's start drawing these. First, we're going to have our total variable cost curve. Now your total variable cost curve is going to start at 0. Remember, this is all of your labor cost. Now if you're not making any output level, then you don't have anybody working for you, so your labor cost is 0. Now when we draw our total variable cost curve, pay attention to the shape that I'm going to draw. It's going to be really steep at first, and then it's going to kind of be a little less steep, and then it's going to turn and go steep again. But notice that it is always upward sloping. It is always an upward sloping curve, only it's steep, a little less steep, and then it gets very steep again. Now, why does it have that shape? Remember how we said marginal is the slope of total. That means that marginal cost is the slope of total cost. Well, remember our marginal cost curve. It's a Nike check, and it never goes negative. It's always positive. So if your marginal numbers are always positive, then that means that your total curves always have a positive slope. That means they're always increasing. Now, your marginal costs are high at first, and then when your workers are really productive, those costs fall. So these numbers your marginal numbers are going to get a little bit lower. Well, if your slope numbers are getting lower, that means your hill is getting a little bit flatter. But that doesn't last forever, because whenever your workers get too crowded and things get chaotic and out of control, your marginal costs are going to turn and skyrocket. And when those numbers really go up, your total costs really get very steep. So these total curves have this weird backwards S-shaped looking appearance because of marginal being the slope of total. Let's draw your total cost curve. Your total cost curve is going to be parallel to your total variable cost curve. Remember we said yesterday, total cost is your total fixed plus your total variable. So if your total cost goes up by $400, none of that $400 could have come from total fixed, because total fixed cost never changes. So that $400 must have come from total variable cost. So remember how we said any change in total cost is equal to the same change in total variable cost. So these two curves on this graph are going to be parallel. In fact, the space between two parallel lines is always the same amount. So total fixed cost is going to be that constant space in between these two parallel lines that never changes. Now notice that your total cost curve doesn't start at 0. Your total cost curve starts a little higher up on the y-axis. Why do you have some cost even if you're producing nothing? Well, that's your fixed cost, right? You have your rent that you have to pay even if you're producing nothing. So your total cost is going to be up on the y-axis. Now, how do we read our total graph? It's going to be easy, guys. You're just going to go up and hit your total curves and read off the dollar value. So suppose we're reading this at a quantity of 1,000. So if we start at a quantity of 1,000 and we're trying to figure out how much total cost is, well, let's just go up and hit that total cost curve. Then just go over to your y-axis and read this number straight off. Since our total cost curves are already on this graph, we don't have to multiply to get them. We just hit the curve and read off the dollar value. So at a quantity of 1,000, when we hit our total cost curve, it's worth $6,000. It's a big number. Why? Because it's how much to make everything. If we're trying to figure out our total variable cost, start at your quantity, go up until you hit your TVC curve, and that's $5,000. Just read it straight off the y-axis. And then if you're looking for total fixed cost, so all you have to look for is the difference between your total cost and your total variable cost, that constant gap. So between 6,000 and 5,000, your total fixed cost is 1,000. You may think that's all you can find from this graph. It's a total graph, so you may think all you can find is your total cost curves. But with a little bit of math, you can find your averages as well. Remember that any average is just total divided by quantity. Well, we've got all of our totals. We just found them. So if we take those total cost values and divide it by our quantity, instead of how much it costs to produce everything, that's going to tell us how much it costs to produce just one thing. So if we take total cost divided by quantity, then our average total cost is $6. That means it costs $6 to make just one thing. If we're looking for average variable costs, then we're just going to do 5,000 divided by 1,000 is $5. So you're spending $5 in labor to make one unit. And then if you're looking for average fixed costs, you're just going to do your total fixed cost divided by your quantity. So 1,000 divided by 1,000 is just going to be 1. So your average fixed cost is $1. All right, guys, we're going to keep working on this, but until then, check you later.